Welcome to EDU World Space.
Okay, we have a secondary alkyl halide, specifically chloroalkane, and a potential solvolysis. We're doing this in methanol. So note that we have a secondary alkyl halide, which means that E1, E2, SN1, SN2 are all possible, but we have a very weak nucleophile, weak base, so more than likely is going to be E1 or SN1. And in particular, we have a polar protic solvent and nucleophile, which would support SN1, right? So we should expect then to get a methoxide where our chlorine once was, and that because it's SN1, right, we'll get a racemic mixture of both possible enantiomers. Okay, next, we have a bromoalkane with sodium iodide in a polar aprotic solvent. Okay, this is classic SN1. I'll say. This is classic SN2 conditions, right? Strong nucleophile, primary alkyl halide, polar protic solvent. So we should just get replacement of bromine with iodide. All right, next up, we have a secondary alkyl halide, and we have sodium methanethiolate, and we're doing this in acetone, polar aprotic solvent. Again, classic SN2 conditions, specifically because our methanethiolate is a sulfur anion, right? Completely non-basic, but very strongly nucleophilic. So we have a strong nucleophile secondary alkyl halide and a polar aprotic solvent. We should expect SN2, which will be replacement of the bromine and inversion of stereochemistry. Okay, finally, we have a bromocyclohexane that's sort of locked into position by an equatorial T-butyl group. And we have sodium thiolate, again, in acetone, right? And these are, once again, classic SN2 conditions, strong nucleophile, secondary alkyl halide, and a polar aprotic solvent. We should expect, again, displacement and inversion of stereochemistry, basically meaning that the sulfur will come in from down here, the hydrogen will get kicked up as the bromine gets kicked off. And our product, if we want to respect the chair conformation shown, which is essentially locked in by that T-butyl group, then would be that hydrogen is now pointing up, and our new thiol would be the lower of the two substituents in equatorial position.